Hi guys, today I would like to start new concept motion in a straight line. Let's get the introduction about this chapter. So whenever we look certain objects, so certain objects are at rest, just like this balancing stones and the leaning tower of Pisa. So these objects are at rest, and if you can take certain objects and they are in motion. So the galaxies, the stars, the planets, and our heartbeat, or any kind of race between rabbit and tortoise. So this everything is in motion. Perfectly, we can say that. So according to science, in this universe, no object is at absolute rest. Absolute rest means it is always appears to be at rest. So there is no object is like that. Every object it is in motion. There is no object in this universe you can say that object is at rest, absolute rest. So let us jump deep inside. So what is this motion? So when it comes to the macroscopic, we saw these planets, galaxies, and these are in motion. When it comes to microscopic, these molecules and atoms, they are also in motion. So even though if you can take the atoms in a substance, so we can say that atoms in a given substance, it is also in motion. So there is no substance at absolute rest. We cannot say that. So let us guess the natural phenomena of sunrise, sunset, and seasons, and these all causes due to because of what? So by observing this figure, so you can guess that what could be cause for this phenomena. So let us define motion. Motion can be defined as change in position with respect to time. So we can say motion is change in position. Suppose if you are going to your house to your friend's house, so you need to change position from your house to your friend house. So it means you need to move. So that is only we can say motion. Motion can be defined as change in position with respect to time. So there is always time will be there. So the time also needs to move. So this is the simple definition we can take in motion. Motion can be defined as change in position with respect to time. Now, if you can see further, the types of motions. So as we are discussing about motions, and these motions are more complex. Some objects they move in straight line, some objects they move in circular path, some may move rotatory motion, and some may vibrate. So these are the different types of motions. Motion in straight line, motion in circular path, or motion rotation and vibration. Just see the straight line motion. So just like march fast, motion in a straight line. So the all soldiers are stepping forward in the same direction in the same time. So this is known as motion in straight line, or this is also known as rectilinear motion. Motion in a straight line, also known as rectilinear motion. So if the objects are moving in a straight line, perfect straight line, so that we define as rectilinear motion. Now let's see the another kind of the motion. Motion in rotation. So in the rotatory motion, the objects will move about an axis. Just like see this wheel, the wheel is supposed to rotate about an axis. So that is the rotatory motion about an axis. And here the gears also moving about an axis. So this is also, you can say, it's a rotatory motion. And see the vibrations. So this is one of the molecule. If you can take that as a carbon dioxide. So the molecules or the atoms in the molecules, they are not at rest. They are in motion. And these motions are certain complex. It's not that easy to prove and to understand that. We need a good mathematical support. So this tells about the vibrations and the vibration motion. So in this chapter we will learn only straight line motion. That is our chapter name. It's also motion in straight line or rectilinear motions. So I confined particularly in a straight line motion. Or you imagine like this, in this universe, so we are having only x-axis. In this universe we are having only x-axis. Everything has to happen in the x-axis. So because x-axis only you can take as a straight line, perfect x-axis, positive x-axis or negative x-axis, that is only existing in this universe. So we all are living on that. So when we can move, either we have to move forward, either we have to move backward. So that is only, we don't have any another things. So that we can say that motion in a straight line, only a single line. So let us understand certain basics which we already learned, which we already know that. So this straight line motion, I would like to represent this a beautiful march past done by the soldiers. So this tells about a rectilinear motion. Now before defining motion, we must set up an origin and a position direction. Suppose as per I said, so I am only talking about motion in a straight line. So I am having this only x-axis. So in this x-axis only I need to move. Suppose in this x-axis, if you can draw like this, it is a positive x-axis and it is negative x-axis. We can take middle somewhere as the origin. It's supposed to exist origin. So that origin we can take as a reference point. This is called as a reference point. Reference point or origin. So to describe the motion, so that reference point is very important. So that reference point, usually we can take that as the value x equal to 0. So with respect to that origin, we would describe the motion ahead. So to understand motion carefully, so this reference point is necessary understanding concept. The origin, that is you can free to choose, that is it is not a compulsory, it is only one particular point as an origin. So the convenient point to describe the motion is an origin that has to settle. And in this same picture, if you can understand the arrow marks indicates that the way it is showing as an with respect to origin the positive direction. So when if you are moving from one point to another point, initial point to final point, so you are moving in this particular direction. So we can define your motion on this axis with respect to this reference point. So if you understand that reference point, so it is easy to describe the motion. So let me take one example at here to make you better understanding. So the same thing, suppose this is your house. So your house is in between this grocery shop and your friend's house. Suppose if you want to move from your house to your friend's house, if you want to move, you want to go to your friend's house. So you have to move in this direction, in that particular direction. Now, I have taken your house as a reference point because to describe motion, what does it mean the describe motion? Suppose if you want to say that how far you are moving from your house to your friend's house. So from at here it is a 2.1 kilometer. So I need to calculate that number 2.1 kilometer. So how can I measure the 2.1 kilometer? So with the help of reference point, I have chosen your house at x equal to 0 as origin. So this is my reference point. So this is origin. So from the origin, so the direction you are moving, so that direction we supposed to take as positive direction. Since the way you move from the reference point, so that takes as positive direction. So from this example I can understand that, so I am moving at a distance of 2.1 kilometer. So the 2.1 kilometer is the distance from your house to your friend's house. So the 2.1 I have calculated by choosing the reference point. Similarly, if you are moving to another direction with respect to reference point, you are coming to as a grocery shop. So it is at a distance of 4.3 kilometer. So we can say the distance here equal to 4.3 kilometer with respect to the reference point of your house. Now suppose if I change the reference point, now if I change the reference point, now I have chosen your friend house as a reference point. I have chosen your friend's house as a reference point. Now if your friend house is a reference point, now when we describe the motion, then there is a little change. Suppose you are moving from your house to your friend's house. Now here we can say that the reference point has changed. Now the distance, the measuring distance here equal to 2.1 kilometer. That is also same, but the change is only reference point, nothing like that. You can measure from any point, you can take it, there is no problem at all. But to measure the distance, it's not happens. But when it comes to as a direction quantities, by the times we need to be little careful at that point. So whenever you are moving forward direction, so your motion direction itself you can take it as a positive direction. And if you can change the reference point, and the describe of the motion gets changes. So that we will understand by certain measuring certain quantities, just like velocity and speed and all, so that we can understand it. And one more point important, that after the reference point, motion is a relative. Rest and motion, they both are relative. They are relative terms or opposite. Rest and motion. So here one small observation you need to do, because whenever you can say an object at rest, so that is with respect to what? Now here you can see you are observing as two different pictures. Now if this girl is looking outside environment, outside world, from the moving train, suppose this train is moving. Now this arrow mark shows about that. Now this arrow mark shows about the direction of the bus or train. Now this girl thinks that the outside environment is moving with respect to her. That's what we feel. And if we are looking from the outside, what we think, that the girl is moving. So because this motion, whatever we describe, that is always relative with respect to something. So an object may appear to moving from one person and stationary for some other. Now if you can observe the passengers inside the bus, when they are look each other, suppose these two passengers are looking each other. So when they are look each other, what they think? So they think that they both are at rest. Yeah, it appears they both are at rest. But when we are observing from outside, they both are moving. So that's the what the word meaning of relative. But when they observe us, the persons who sat inside the bus are observing outside, they feel that the outside environment, the outside world is moving. So because the motion is always comes with a concept of relative. So this concept we will understand deeply, the concept of relative in the coming topics. There is a good physics exists, which is developed by Albert Einstein, relativity. So according to that relativity, we can describe even the complex motions. So those concepts in this we are not touching, but we can touch a small concept. So yet here I would like to introduce a term known as reference of frame, or a frame of reference. What is this frame of reference? So to describe any motion, we need a coordinate system. So because we need to talk about the motion with respect to mathematical help and certain scientific terms, so in the open space we cannot describe the motion. Suppose I want to describe the motion of a particle in the air itself. I want to locate that particle in this air. So to describe that, we are depending upon a term that is known as coordinate system. So this term is not new for us. So in a simple language we can say that it is nothing but a three-dimensional graph. Or first let me take a one-dimensional and two-dimensional. Suppose we already know this x and y axis. So this is nothing but I can take this as a coordinate system. So this is a two-dimensional coordinate system, or this is also known as Cartesian coordinate system. This is only having two dimensions, x and y. So where we can take origin, usually we can take origin at here, and this we can take as positive x-axis, and this we take as negative x-axis, and this is negative y-axis, and this is this is positive y-axis. So this we can call a two-dimensional coordinate system, since it is having x and y axis, or we can say this is one of the plane, xy plane. Suppose in this one I am having a clock. Suppose if I take clock at here, so this is my clock. So the clock is ticking. So this is clock. For a moment, let's consider this is a clock. Now, yeah, in this xy coordinate system or on the screen, one particle is just moving like this. So just moving the particle, it is moving just like that. So I want to notice the position of the particle after 5 seconds. I want to just notice the position of the particle. Initially this is starting position with respect to A. If I can take, this is A, and after 5 seconds the particle went up to at here, this position is B. Now can I locate the particle initial at A, and also after 5 seconds, can I locate the particle? Yeah, I can easily locate, because I am having this coordinate system. So with respect to coordinate system, I can show that the particles with respect to x-axis, the position I can take, this is the corresponding the point, and the same I can take, this is the corresponding point with respect to y. Suppose if I can take this as 2, and this is also 2, here it is 1, and here it is 1. The location of the particle as 2 comma 2. So I can simply locate the particle with respect to reference point in the x and y coordinate system. Now initially that is 2 comma 2 is the position or the location of the particle, and after 5 seconds, the particle is at the location of the B. Now I want to locate the particle on the xy plane. So let if take this as a point 8, and the corresponding, if you can take, this is a point 4. Now the location of the particle at 8 comma 4. Now initially the particle at 2 comma 2. Now the particle at 8 comma 4. We can locate that with respect to the corresponding x-axis and the corresponding y-axis. That is easy to locate. So here I can able to locate with the help of this origin, because origin I can consider that as 0 in the 2 dimensions. So likely if we can describe the position of the particle in the 2 dimensions or the 3 dimensions. Suppose if I can take again 2 dimensions, I want to locate the particle. So with respect to origin, so I can locate it. It is easy. So if this is the position of the particle, now we can say the particle is at a distance of the corresponding x-axis, and the particle is at distance corresponding the y-axis. Since it is having as an origin, it is x comma y. So this origin we can take as a reference point. So likely we can consider in the three dimensional also. So it is a little difficult to me to show three dimensions, but if you can know the language of three dimensions, instead of the two dimensions we are having as we are having x, y, z axis. So the z axis, you can just imagine that inside the screen, that is z axis, x axis and y axis and z axis. So in the three dimensional, if you want to locate the particle in three dimensions, so in the three dimension, even though the particle in the air itself, we can easily locate with the help of this coordinate axis, or this is known as the reference frame what we set up. So this we call it as a reference frame or frame of reference. If we change the frame of reference, the location and the position of the particle gets changes, and we can choose freely. We can choose freely the frame of reference. So let me take an example. Suppose when you say that a car is moving on a road. A car is moving on a road. Now in that situation, you are describing the car with respect to a frame of reference that is attached to you, or that is attached to the ground. So then only we can feel that our point as a reference point. So with respect to us, the car is moving. Suppose if you can take this experiment. Suppose you want to describe the motion of a car. Now you sat inside the car next to the driver. Now can you say that the car is moving now? Now you cannot say that car is moving. Now you can say that the car is at rest. Because since you have taken you are as a reference point or frame of reference, so we feel that since the frame of reference is attached to us and I went and sat inside the car, so with respect to me, the car is not moving since we both are in motion. So this is what something you need to understand. So now I can say the same experiment. When you say that a car is moving on a road, so you are describing the car with respect to a frame of reference that is attached to you, or the frame of reference is attached to the ground with respect to ground or with respect to you. But with respect to a frame of reference attached with a person sat inside the car, a person who sat inside the car, just like at here. So it is helpful to show the slide. Yeah. So here the persons who attached the frame of reference who sat inside the moving bus. So the frame of reference is sat with respect to here. So now we can feel that, so it is 0. It is not moving at all. Now with respect to this one, now the car is at rest. But with respect to ground, the car is moving. So finally I can say that to describe the motion, we need to take help of a coordinate system. that coordinate system may be one dimensions since it is having only x-axis, or if it is a two dimensions we can take that x comma y, and if it is three dimensions we can take the x y z, and this rest and motion always relative. And this frame of reference, if you can change the frame of reference, so the motion of the object gets changes. So in this chapter we are describing the motion along a straight line. We can choose an axis, let's say x axis, so that is coincides with the just the path of the object. So in the motion in straight line I am going to take only the coordinate axis, only the x axis. Now we can describe the motion with respect to x axis. Now in the next concept I would like to recall the very basic concept what we already know about the distance and path length, velocity, and like that.